Welcome to this lecture session. In this lecture session, we are going to talk about logistic regression. So firstly, let's go deep dive into two type of tasks. First, linear regression tasks. So in the linear regression type of tasks, we had something that is predicted value is continuous. We predicted home prices, weather prices, stock prices based on some historical data sets. That was linear regression. So whenever the predicted value was continuous, what I mean by continuous is whenever your data is on some standard scale, like home prices will be on dollar, on some monetary value, weather will be on some temperature and some humidity, some level, some degree or some so on. Similarly, stock price would be also some monetary value. So whenever your predicted value, the value that you are going to predict is continuous, is on some scale, then you use that is linear regression. Now the tasks, that is basically that is going to be containing some of the classes, like whether the email is spam or not. So we have an email and you are going to predict whether that email is spam or not. So you can see you are going to basically have two classes. In the case of this example, we will have spam regarded as one class, not spam as a zero class. So there is a classification problem. Whenever your problem is basically the prediction value, the value that you are going to predict belongs to some classes, then it is a classification problem. Like in the second example, you can see, will a customer buy life insurance or not? Yes or no. If he will buy, then it is yes. If he doesn't buy, there is a no. So that means it is within a domain, within certain finite classes. Our predicted value, the value that we are going to predict will be on certain domain. So if it is not in domain, if it is not bounded, then this is linear regression. If it is on some boundary, we have to bound that predicted value, then it will be our classification problem. Like we can also say which party a person is going to vote for. So we have domain, some domain, and the people can only vote on these parties. So these ranges of parties. So that means it is also some domain. So whenever your predicted value is under certain classes, under certain, that is domain, under certain boundary, then your task is classification task. But when your prediction, the value that you are going to predict, is not under certain boundary, it is continuous, it is unbounded, that means it is regression. If your predicted value is bounded, that means it is a classification. Now classification has two types, but before that, logistic regression is used for classification. So we use linear regression. If you remember, we have completed all the tasks related linear regression. We saw simple, multiple, polynomial and multivariate linear regression. Those tasks was certainly for regression. Now we are learning logistic regression. So the logistic regression is used for classification. So don't get confused with the naming here. Although name has regression, but it is used for classification problem. So classification means there should be some classes. Our prediction should be bounded between certain classes. So logistic regression is used for tasks of classification. So let's see the classification types. So we have some example like, will customer buy life insurance or not? Like we have two classes here. We are only bounded with two classes, whether he will buy or he is not going to buy. So in that case, we have the option that is only two, and from these two options we are going to predict, and in that case it is binary classification. So binary classification means you have only two options. Binary means two. So you have only two options from which you have to predict. Similarly, the example like which party a person is going to vote for, you have more than two options. It can be many options, more than two, but it should be finite. Just remember, it should be finite, but it can be anything that is more than two. Any classes that is more than two, then that is multi-class problem. So here classes means this domain. Like in this we have two domain, that is either he will buy or he is not going to buy. So this yes is one class, no is another class. Over here, this democratic is one class, republican is another class, independent is another class. So here we have a multi-class problem. So whenever you have a classes that is greater than 2, then that is multi-class problem. So logistic regression is better in order to deal with binary classification. Either customer will buy or not buy the insurance. Will customer buy life insurance or not? So in this type of problem, like in binary classification problem, although it can do the multi-class, but we will use more complex model that we will be learning in upcoming courses, like neural network will be used for multi-class classification. But in the case of this binary classification, logistic problem will be useful. So now let's see some of the details of this logistic regression. We are going to start with hypothetical function, and next cost function, and then we are going to talk about logistic regression with gradient descent. This all concept will be covered in the upcoming series of lecture. We are going to start with hypothesis representation in the next lecture.